How will the universe end? In 1929, Edwin Hubble discovered that the universe is not in fact static but expanding. In the years following his discovery, cosmologists took up the implications of the discovery, asking how long the universe had been expanding, what forces caused the expansion, and whether it will ever cease. Cosmologists are pretty confident about the first question, just shy of 14 billion years. A great deal of evidence supports the predominant answer to the second question. The universe rapidly emerged from a singularity in an event that cosmologists call the Big Bang. The third question is a bit more mysterious, and the answer relies on an obscure, confounding phenomenon known as dark energy. The density of dark energy in the universe determines its ultimate fate. In one scenario, the universe does not possess enough dark energy to forever counteract its own gravity and thus ends in a big crunch. Under this scenario, the universe's gravity will overcome its expansion and the cosmos will collapse in on itself, resulting in a singularity that may precipitate another Big Bang. However, the evidence cosmologists have gathered over the last few decades leads us away from the scenario. For the big crunch to occur, we would see signs that gravity was winning out over dark energy, slowing its expansion. However, measurements of distant galaxies indicate that cosmic expansion is not slowing down, it's speeding up. Apparently, the density of dark energy in the vacuum of space is simply too high to permit a big crunch. That leaves two possible fates for the cosmos. First, a big freeze, in which the acceleration eventually halts but the universe keeps expanding, creating a system where heat becomes evenly distributed, allowing no room for usable energy to exist, and thus heat death. Second, a big rip, in which the expansion of the universe continues to accelerate forever. In the former scenario, the universe will progressively become darker and colder until the end of time. In the latter, all matter down to the most fundamental particles will be torn asunder. All the recent data from the Planck Space Observatory and the Sloan Digital Sky Survey suggest there is just enough dark energy to continue the universe expansion, but not enough to keep it accelerating forever. This conclusion points towards the big freeze or heat death of the universe. The most up-to-date science leads us to the conclusion that our universe and Robert Frost's is more likely to end in ice than in fire. That, however, assumes that what we believe about dark energy is true, considering that dark energy itself is a phenomena cloaked deeply in mystery. Such assumptions may yet prove untenable.